Hello everyone, welcome to this presentation. Today we are going to give an overview to data science. Data science big data has one of the largest markets today. According to IBM report, there is a need for 1.5 million data scientists in the near future. Let's look at a picture. It shows a person who is trying to find a way out of a place where his boat was surrounded by humongous amount of data. Not only that, the data has many different formats. For example, images, internet text, scientific data in multidimensional space, data streams, social networks, and the security purpose data. This person could be you, a future data scientist. Now, we're going to define what data science is. Data science is an emerging field driven by big data. We can also say that data science means data containing science. Someone also think data science is something we want to look inside. Now we want to review big data technology. We usually refer to 3 V's. First, data sets come from many sources in different formats. Variety. The size of data is in gigabytes, terabytes, and petabytes. That requires massive storage. It is related to volume. And also, we want to use fast computing facilities. It requires cloud computing and the computers. That relates to velocity. And someone added another V called veracity. It means different quality of data may be added. It should be considered or should be traded. For the data science technology, we want to say that statistical methods are still primary methods, as well as machine learning methods, especially data mining. The graph method, hybrid method including neural networks for deep learning. Some mathematicians are working on topological method called persistent data analysis that could be an effective one to data science. Do we have tools available for data science? Yes, we do. We currently have Hadoop, Spark, TensorFlow. TensorFlow software was released last year by Google company. For the current trends, we wanted to say that the local or small processing, we still use statistical methods, but for global analytics, we'll be using artificial intelligence or other computer science methods. I would like to add, data science may yield revolutionary breakthroughs in science and industry. From the technological point of view, we have 5 key IT technologies today: mobile phone, social networks, big data, analytics, and cloud computing. I would like to make a definition, the data science, big data plus analytics plus cloud computing. This is the end of the first part of the presentation today, that is the definition. Next, we want to get into details of big data. As we said that big data is a phenomenon in current problems regarding datasets. The characteristics of big data are large data volumes, use cloud computing tech, high level of security, potential business values. It's not only potential, now we can see the huge business values and the many different data sources and the formats. Okay, let's get into the idea of what big data is. As the petabytes age, as we refer to today, we can see that kilobytes, it means 2 to the 10 or 1024. That means 1 followed by 10 zeros in binary. The megabytes means 2 to the 20, 124 times 124. Gigabytes is 2 to the 30. Terabytes, 2 to the 40. Petabytes is 2 to the 50. That means a petabyte is 1 million times 1 gigabyte. Exabytes is 2 to the 60. Zettabytes is 2 to the 70. Yottabytes is 2 to the 80. Now we wanted to talk a little bit about and where big data come from and what we can do about it. In 2008, Walmart has around 267 million transactions per day at their 6,000 stores worldwide. In 2014, Walmart handles more than 1 million customer transactions every hour. That means we need process 2.5 gigabytes of data a day. This is equivalent to 167 times of the information contained by all the books in the Library of Congress in United States. We also can say that many scientific disciplines have become data-driven. A modern telescope is recording 30 trillion bytes of image data every day. And also, astronomers will apply massive computing power of the data to probe the origin of our universe. It means 15 petabytes annually. And also, we want to see the Twitter produces probably 5, not only the size of the data, but also different types of data matters for the processing. We have structured data, tables, relational database like Excel, Oracle, and MySQL data. We also have text data. It is related to web. Most web data are text data. And the formatted data, text data, which is used by computer professionals. It's called XML. They transfer data to some applications. And graph data, because of social networks, we don't know which location of the person, where the person is. So where the station is, we have a graph data. And we also have image and the videos that are real big data. Stream data only use once. You can also see here, we can see the first picture indicates the internet usage in United States. The second one, facial recognitions. And the third one is graph data, a center station linked to lots of substations. Where are big data stored? We have two primary sources for data, big data. One is online data, and we have some tool called OLAP, Online Analytical Processing Tool. Another one is called the data warehouse. The example of data warehouse is like it is showing the picture on this slide. We can see here we have thousands of computers and probably several storage like this for data warehouse. And some data, because not only relational database, and people are developing some database called NoSQL. That means not only relational database. Some tools are available, developed by Hadoop or other companies. For example, the tool Hive can be used to access online data and data warehouse data. Here is an example for the big data solution from Walmart. We can see that architecture of this Walmart solution, we have different layers. Now we want to make the presentation a little bit